stage. All. Sixteen and 17 is still 1 XX. 17, 16, 16, 17, 17, 16, 2. Transfer this 2 thing, like this one, from stage 17 to 16. And we're gonna get the truth table of this, and then we're gonna find out the output of this table. Like all of this output is 0 except this stage and this stage. One of this should be 1, 16 and 18. One of this should be 1, and one of this should be 0 to swap it. And then we can create the equation of input and output of D1, D0 to D4. To discover the equation, we need to focus on the D0 to D4. D0 is this digit from all of the input. Need to focus on the last digit. This is D0. So we can write down all of the input. From the 0 so 0xx has the same input, so we can write it down like this. stage 18. We can use this equation to describe the input of each state. And then the next term is 1, x is all the same. 1, 100, 101. Okay, just this 101. And write down the state 3, 2 to 16, 2 to 16. One, 14 and 16. Sorry, but I have the wrong state. It should be 1110, and this is 1. Okay, I cut the wrong one a little bit. Yeah, I have transferred the wrong one. So D0 should have only 16. So this is the equation of D0, and we're gonna move to the D1, to the next digit. D1. In D1 we have 0xx for the same result. 16, 17, 18, 19. Sixteen, 17, 18, 19, and then 100, and 101 is exactly the same. 100, 101, 1, 2, 3, 6, 7. 1, 2, 3, 6, 7. 1, 2, 3, 6, 7. 10, 11. 14, 15. 10, 11, 14, 15. 10, 11, 14, 15, 18, 19, 18, 19, and then 110, 110, 1, 2, 110, 1, 2, 6, 1, 2, 6, 9, 10, 14, 18, 19, 6, 9, 10, 6, 9, 10, 14, 18, 19, 14, 18, 19. And then 111. 1, 2, 5, 6. 1, 2, 5, 6. 5, 6. 10, 13. 10, 13. 16. 16. Okay. And then D4, D2, move to the D2, D2 only have 100, 100 and 101. Four, 5, 6, 7. 4, 5, 6. 7. 12, 13, 14, 15. 12, 13, 14, 15. 110, 110, 110. 4, 5, 7. 4, 5, 7. 7, 11, 12, 14, 11, 12, 14, 11, 12, 14, 1, 1, 1, 4, 5, 6, 4, 5, 6, 4, 5, 6, 12, 13, 14, 12, 13, 14, 'done for the 2 to the 3, move to the 3, D3 only have 100 and 101 and all the same. From 8 to 15, 8, 9, 10, 11, 12, 13, 14, 15, and 100, 110, from 8 to 12, 8 to 12, and 14, 14, 111, 7, 8, 10, 7, 8, 10, 7, 8, 10, 12, 13, 14, 12, 13, 14, 12, 13, 14, through D4, D4, (16 to 19), 16 to 19, 16 to 19 and 16, 17, 16, 17, also 16, 16, 17, and 15, 16, 17. Okay, so we are finally got all of the input for each D to create the circuits on the simulation for OR gates into the multiplexer for each one. So we're gonna move to the simulation program Quartus. And this is my circuits, and in the middle of this circuit is the equation of the output that we just create for D0 to D4. This is the flip-flop we use to know what state we are using, and this is the decoder. We use 2 to 4 and 3 to 8 decoder. And then this is the multiplexer. Then I'm gonna show you how to run the program and what the output of this diagram. Now we need to set up all of this. So now we got the diagram ready to source the MOSI, which is my ID in binary. For the first one, I'm gonna add the correct data which is 0110011, and the next one is the wrong data in the first state, and the second digit and the third digit in the incorrect one. And we're gonna see what output is gonna be. in the correct one, it can turn to the last state, which is 19, and turn to the 2 state, the second state, to run the program again, to run the circuits again. And the wrong one, the state turn to the 0, which is correct for the wrong case. And the second one turn to the 0, and the third one is turn to the 0, same. So it can tell you that the state that we create is true, is work. And then we're gonna change the fourth, need to be 1. And the fifth one need to be 1. And the sixth one, I'm gonna check all of the digits. We have 7 digits, right? So I'm gonna use the incorrect data to check if it's work. And now we have all of 4, 5, and the 6 digits. We're gonna run again to check. Okay, you can see that the state it turned to the 0, which is, it should be like this because it incorrect data source into this program. Also the 4, 5th, 6, and 7 digit, the 7 digit. Okay, so we can prove that this diagram is work.